Welcome to This Explainer. Today, we're breaking down exactly what sets your favorite beverages apart, and we're exploring the seriously fascinating science of how they're actually made. We're going to take a journey from the simplest natural processes all the way to the absolute extremes of modern chemistry. I mean, we've all seen the massive shelves of beer, wine, whiskey, and vodka, right? You probably already have a favorite. But today, we're mapping out exactly how they differ from one another and answering a pretty great question: which one truly holds the highest alcohol content? By the time we wrap this up, you're never going to look at a drink menu the same way again. All right, let's jump right into section 1, the foundation, which is all about fermentation. At its core, yeast is kind of the unsung hero of the entire beverage world. You can think of yeast as this tireless, microscopic worker. When you introduce it to a base liquid, it basically feasts on the naturally occurring sugars. And as it breaks those sugars down, it creates two really crucial things: carbon dioxide, which just safely evaporates away, and alcohol. This amazing natural process gives us what we formally call fermented alcoholic beverages. Now, the flavor of your drink completely depends on where you actually source that initial sugar. It's like picking a canvas for a painting. We can extract sugars from cereals, fruits, or plant extracts. So if you use grapes as your base, you get wine. If you use barley, you get beer. It's the exact same fundamental process, just utilizing a totally different sugary canvas. And this perfectly illustrates the natural limit of fermentation. If you check the ABV, that's alcohol by volume, on a label, you'll see that purely fermented drinks like beer usually sit around 4 to 6%. Wine pushes a bit higher, generally hitting roughly 12 to 15%. But nature literally has a cap. Yeast can only survive in so much alcohol before the whole process naturally shuts down. So, what if you're looking for something a bit stronger? That brings us to section 2, distillation, or raising the bar. Here's how it works. We take that fermented drink and heat it up to roughly 75 to 80 degrees Celsius. Now, why that specific number? Well, water boils at 100 degrees, but alcohol evaporates earlier. So at 80 degrees, the alcohol turns into vapor and escapes, leaving the water behind. We then catch that alcohol vapor, cool it down until it turns back into a liquid, and boom, we have a distilled spirit. The really crucial takeaway here is understanding this massive jump from a simple fermented beverage to a highly concentrated distilled spirit. A spirit is basically the pure, potent essence extracted straight from a fermented drink. Because it goes through this intense heating and cooling cycle, it enters an entirely different class of beverage altogether. By stripping away all that excess water, this distillation upgrade results in spirits that pack a way heavier punch. Remember how wine stopped around 15%? Well, your standard distilled spirits generally range anywhere from 40 to 60% ABV. It is a massive leap in potency. Now let's move on to section 3, the spirit family tree, and see how this builds into the vast variety of drinks you see at a bar. It all comes back to what you fermented in the first place. If you start with sugarcane juice or molasses and distill it, you get rum. If you take wine or fruit like grapes and distill that, you get brandy. And if you distill a fermented grain mash, which could be barley, corn, rye, or wheat, you've got whiskey. Oh, and Scotch is just a highly specific kind of whiskey right under this umbrella. The family tree expands even further when you travel the globe. Vodka was traditionally made from distilling liquid from potatoes or grains, though today you might see corn, rice, or even fruit being used. Tequila, on the other hand, is extremely specific. It is exclusively crafted from the blue agave plant, mostly right around the city of Tequila in Mexico. Now, a really unique detour in this process is gin. It starts out a lot like other spirits, usually from grains like wheat or barley, but then it takes its own path. It gets redistilled, often multiple times for purity, and during that final run, distillers add botanicals. The absolute undisputed star of the show here is the juniper berry, which gives gin that highly distinctive piney flavor we all recognize. Finally, we've arrived at section 4, liqueurs and extreme ABVs. We've covered the standard spirits, but what happens when distillers push the absolute limits of science? Well, first up, we have liqueurs. If you take those really strong, high ABV spirits we just talked about and sweeten them up by adding fruits, herbs, spices, and extra sugar, you step completely out of the pure spirit category. These sweetened concoctions become liqueurs, and they give us that huge, colorful range of flavors you'll often see in complex cocktails. But on the total opposite end of the spectrum from sweet liqueurs, we have the pure powerhouses. Remember how gin used redistillation? While distillers can use multiple rounds of relentless redistillation with one single goal in mind, stripping away absolutely everything except pure ethanol. This intense scientific process creates literally the strongest liquors in the world. We aren't talking 40 or 60% anymore. Everclear hits an astonishing 95% ABV, and the Polish spirit, Polmo Spiritus Rectificowany, reaches a staggering 96%. It is virtually pure alcohol, sitting right at the very edge of what is physically possible to distill. Knowing that science can push alcohol content all the way to a shocking 96% perfectly underscores the golden rule of everything we've learned in this explainer. The leap from a 5% beer to a 40% whiskey, let alone a 96% spirit, is absolutely massive. So always check the ABV on the label, know exactly what's in your glass, and always enjoy it responsibly. So, we've mapped out this crazy journey from simple grains and microscopic yeast through the very clever science of distillation all the way up to 96% spirits. I want to leave you with this. After seeing exactly how it's crafted from start to finish, what is your favorite drink? And knowing the science behind it, why do you love it?